Hi, I'm Liam, and this is my Project 2.5b, which is a control of my previous homemade 5-volt relay. What I chose to do for this project was following similar lines, some homemade RF communication, and I used that in addition to the relay to power this fan, which I made with a motor and just some cardboard, as you can see in front of you. So now let's move on to a demonstration of the transmitter and receiver in action. So here you can see that when I press this button, the relay switches and the fan turns on. You can also see that this green LED indicates the data being transmitted. The either on or off state is decided by that switch that you saw me flip. Now, I know what you're thinking, and you're wondering why there's a wire connecting the two, and this is actually a common ground wire. And while it's not necessary for communication, it greatly improves range and also signal connectivity, or signal strength. I actually tried very hard to not have to use a common ground connection, as you can see with this clip here, but this was pretty much the maximum range I could go without a common ground in my testing, and you can also see that the connectivity between the receiver and transmitter was horrible, which can be seen with the flickering of this LED. Now, common ground connections are not actually very rare, and they're applied a lot in the real world, where cell phone towers are actually all rigorously connected to earth ground. And this brings me to the point that a ground wire or a wire connecting the transmitter and receiver is not actually necessary for a common ground connection. For a common ground connection, you could use two giant metal rods, drill them into the earth, and then connect both the transmitter and receiver's ground to those metal rods, which would attach both of them to earth ground. However, I don't have grounding rods, so that wasn't an option for me. Next, I want to talk about something that is very important when building a radio antenna, which is resonant frequency. Resonant frequency in electronics is a frequency where a circuit will oscillate with the greatest voltage amplitude, which is slightly different from the physics definition. In this project, I used a transmitting frequency of 100 kHz, which meant that my antenna circuits had to resonate at 100 kHz as well. A very powerful circuit with a known resonance formula is called the resonant tag circuit, or LC circuit, which is shown on screen. LC circuits are AC circuits with a capacitor and an inductor in series, where at the resonant frequency, the resistance in the circuit will be purely real. Without going too much into depth, this means that at that specific frequency, the reactances of both the capacitor and the inductor will cancel out, meaning that the impedance has a truly real value and an angle of 0. This in turn means that impedance is not needed, as the resistance is not complex, so you have a purely resistive circuit. With this lowest possible resistance configuration, you know that your current and therefore your voltage will be the biggest in amplitude at the resonant frequency. So, that's about it. Thanks for listening.